2 to the power of 5 is what? 32. 2 to the power of 4 is what? Is 16. And 2 to the power negative 1 is what? Is 1 over 2. So that's what they're trying to bring in here. So here you'll have 2 to the power of 5. Then you've got 2a plus 1 times 2 to the power negative 1. You've got a minus 6 is equal to 2 to the power 4. Also, it's good to put brackets so that you can have that. Hello, our most developed student. My name is Confident. Welcome to the full version or a full revision of the Mathematics N2. And this paper was written on the 28th of June. And I'm bringing you here a full version of this paper. And I will encourage you guys, if this is your first time to watch this channel, please subscribe to the channel so that you can benefit from even more and more videos. There is a lot or lots of content here which is designed with you in mind. So if you are interested in passing your mathematics and you are working towards your N2 exams, this is a good chance to get lots of videos. And there is, as I said, quite a lot of content. And if you subscribe, you are able to benefit from everything that I've made as far as Maths N2 is concerned. Not only Maths N2, N1 and N3 are also covered here. Look at this paper. As we say, it was written under 3 hours. You need to write this in 3 hours. The mark allocation is 100 marks. You need to use, what's most important, the blue and the black pen. I've seen students trying to use highlighters. Don't do that. You need to be neat with your work, and also don't come up with your own numbering system. And also, to just clear a few things, others are always asking, what is the marks that they put on this paper? These marks is more like a security feature to me. There is nothing special about it, but just as a security feature from the department on how they can recognize an official paper that will be written for that particular trimester. So this is just that, nothing else I think from this. Now let's look at the question 1. Question 1 says simplify the following without using a calculator, and you are given the 1.1.1 here. Ln, if I can write this, it's e to the power, then you've got ln e to the power of x. See this? So now you are given this, it's 1 mark. I think I've tried to touch on this. They say don't use a calculator, and I always say when they do that, that's when you take the calculator. But now, when you're dealing with ln, if you just do this, if you say ln e to the power 1, try that with your calculator and see what it gives you. It gives me, if I can just take my calculator, if I say here, ln shift e, and then I put a 1 like that, you see, I get a 1. But now, what if I put here a 2? I get a 2, you see. If I keep on put a 5, I get a 5. I put on different number 17, I got 17. Now, which means if I put a 1, I get a 1. If I say ln e 17, I got 17, meaning ln e, then I put an x. What do I get? I get x. So which means this thing here was what? It was e to the power, because it's ln ex, it was e to the power of x. So the answer was e to the power of x. It was 1 mark, you know. So that is that you needed just to quickly solve on that. So 1 mark. Let's look at the next one. It says, so this is EX 1.1.2. We are simplifying logs. Remember they said don't use the calculator. Anyway, that's when I think you must actually be using the calculator. Look at this. It says minus 2 log base 5 of 1 over 5 plus 7 log base 3 of 9 minus log base 5 of 1 to 5 to the power negative 3. Don't worry, I'm going to bring this so that you can see properly. So this is what you're given and you want to solve this. Just let's check if everything is captured correctly. Minus 2 log base 5 of 1 over 5 plus 7 log base 3 minus 5 this. So guys, you are given this thing, and in this thing here of logs, what do? You take your calculator and test your answer. Why do you want to work on something which you have to kind of guess? You need to actually take your calculator and enter this and see what's the answer. Minus okay, how do you punch this on the calculator? You need to be very careful now. Pay attention. You are going to say minus 2, put a bracket first, and then you say log. I'll show you when I don't put that bracket, you'll see the answer will also change. Log 5, the logarithm also put its own brackets, 1 over 5, that's the calculator, and you close the one that you opened, plus again 7. Don't just say 7 log, put a bracket, and then you say log base 3 of 9, and then minus, again there is the part here. What are you going to do with that? I will say, if you're given a power like that, with using the laws of logs, remember this will drop to become minus, and then so it's minus bracket negative 3. That was going to drop to become negative 3. All right, I'll say times, I'll show you why I'm doing what I'm doing, log in base 5 of 125. With logarithms, you just need to be careful with how you put your brackets. That, and then equal to, I'm getting a 79. I hope this was done properly, and you know what, I hope this was done properly here. Minus 3, if I put that again, put a bracket there so that I've got 3 of them. Let me just see what happens. Does it change? 79, it doesn't change. So my answer there is 79. So this gives me 79. So let's work towards that 79. How do you go about that? Okay, by the way, I wanted to show you how the importance of brackets. Look at this. If I say to you negative 2 log base 5, and then I say here 1 over 5. See, I didn't put any brackets. Equal to, I'm getting a 2. Let me put a bracket here like this, like that. I'm getting a 2. Okay, it's the same. Let's try the other one. 7 log base 3 of 9. I've seen something giving me different answer here. All right, is that? I think basically it will still give you the answer, so it's fine. I thought it was gonna give a different one. Okay, let's work on this. How do you simplify the first one? Now the first one is, you need to identify or recognize how to make that base and the number become the same. So what you do is, you recognize that here I'm gonna do my working, that 1 over 5 is same as an exponent. Take this to the top. Remember there's a hidden 1 there. It's 5 to the power negative 1. Why? So that you can have that 5 and you've got that 5. You see that? So you can rewrite this and say, this is same as saying minus 2 log base 5, 5 to the power negative 1. See what I'm doing there? And then plus 7 again, log base 3, convert 9 into 3, which is 3 squared. You're trying to match. And then minus log base 5, identify what is 125. Now 5 to the power of 3 is what? Is 125. So this is 5 to the power of 3, but look at this, you've got brackets times negative 3 outside there. You'll be multiplying that. So this is same as saying equal to. Now using this rule or the law, if you're given log in base a of b to the exponent m, you are allowed to say that m drops down, which is m log in base a of b. M will be multiplying. So again here, you can take that, you drop it. And when you drop it, this is what it does. You're going to say minus 2 times, then you've got a minus 1 that you dropped. And then you've got log 5 base 5. If you want, you can actually put it in brackets like this. Are you seeing that? And then again, you have got this 2, which you are going to drop down there, so that you have got plus 7 times, and then since you are bringing it 2 times, or you can put a bracket, and then you've got log 3 of what? Of 3. Are you seeing that? Same thing now, what you wanted to bring here, this is 3 times 3, which is what? This is 3 times negative 3, because it's multiplying, and this is negative 9. See that? So you're going to say, you drop that 9 also here to say minus, there is a negative sign here, and then you've got a bracket minus 9. See what I'm trying to do? I will have to take this off. So it's minus 9 log base 5 of 5. Look, everything has got the same base and the number, and what am I trying to achieve? I want to use this rule which says log base a of a is equal to 1. That's what I'm using. So here it will be equal to minus 2 times minus 1 is a positive 2 times, remember this becomes log 5 is 1, plus 7 times 2 is 14, log 3 of 3 is 1, and then minus times minus is a plus 9, log 5 of 5 is a 1. See that? So I've got 2 plus 14 plus 9. Now what is 2 plus 14 plus 9? I'm not getting that 79 now. 2 plus 14 plus 9, it gives me actually 25. As I said, you need to be sensitive whenever you are using your calculator into this. So you see now, I didn't get it right. Now let me use my calculator, and I'm going to use it individually, not to punch it once. I think punching it once somehow is the one that gives me the error. So if I say negative 2 bracket log 5, and then here is 1 over 5, see that? Equal to, I got a 2 here, so I'm going to make this is a 2 plus, do the same thing again, it's 7 bracket log 3 of 9, then you close the bracket, it gives me 14. So 2 plus 14, which is what I have here. The problem came on that one there. So if I come in here, I say minus, then I also enter the calculator there to say I have got log, okay, 5. I think that's where the problem is with the logarithms. Look, if I say 125 to the exponent negative 3, what is it going to give me? It's giving me 1 over 27, you see, just with that exponent. But if I do this and say I know 3 will drop to become minus 3 bracket log 5, and then of what? Of 125. equal to, sorry about that, 125 equal to, I'm getting a -9. So I've got bracket -9. That's why it's 2 plus 14, negative becomes plus. So this then will give me a 25. I don't know why the calculator couldn't give me the whole answer straight away. Let's do that again. Let's try it again. Now I'm going to do it once and see actually where it was getting it wrong. Let's do it again. -2 bracket log base 5 of 1/5, and then I have to close that bracket, and then I've got what? Plus 7 bracket log 3 of 9. I'm comfortable using brackets. As you can see, I'm closing that. Don't forget, when you open one, you need to close. And then it's minus, and then it's -3 bracket log 5, and then it's 125 equal to, why is it an error? -2 bracket log 5 of 1/5. I don't see the error here. I opened and I closed. Maybe the problem is that. Let me put a times there. I'm still getting an error. The error actually is coming from here. To say -2 bracket, if I do that, equal to, I'm still getting an error. Okay. Oh, I see. Maybe the way I was putting these brackets, I was supposed to put them outside like that. Perfect. Equal to, still giving me an error. Minus. Now I need to close that one. Equal to, still giving me an error. This one must be minus. Let me remove that. Equal to, okay, it's funny, but there is a 25. Oh, it was actually a struggle to get that, but anyway, it's fine. That is that. With logarithms, you need just to be sensitive with your calculator. Let's look at 1.2. Because of time, let's look at 1.2. 1.2 says solve for a in the following equations, and I've got that. So the first question, this is 4 marks. Let's look at this. Solve for a 1.2.1. What do I have? I have got 32, and then brackets are like this, and then I've got a. Actually, it's 2a, not just a. I've got 2a plus 1, see this, times 1/2, and then it's a minus 6 is equal to 16 to the power -4. 4 marks, guys. I need to solve for a. So here, let's grab this to the clearer side. Okay, let me continue bringing it here to this side. Look at this. So this is what I have. Obviously, when you see exponents, it's laws of exponents that are going to kick in here. They will always give you something that has got like it must make sense. Look at this. 32, 2, and 16. There must be something common, and the common there is 2. What am I saying? You can write 32 in terms of 2, you can write 16 in terms of 2, and you can write 1/2 in terms of 2. So it's always something that they're giving you that is having some hint. Look at this. 2 to the power of 5 is what? 32. 2 to the power of 4 is what? Is 16. And 2 to the power -1 is what? is 1 over 2. So that's what they were trying to bring in here. So here you'll have 2 to the power 5, then you've got 2a plus 1 times 2 to the power negative 1. You've got a minus 6 is equal to 2 to the power 4. Also, it's good to put brackets so that you can have that. So what it means is 5. Now, let me just give this to you to say that 5 is multiplying the 2a plus 1. Always know that. So it's also good to put brackets like this, so that you open it like that. You'll have 5 times 2, 10a, 5 times 1 plus 5. Same thing with the minus 1 and a minus 6. You are opening the bracket and you are opening the bracket, which is negative 1a minus 1 times minus 6 is plus 6. Are you seeing that? So you're going to have 2 to the power 10a plus 5 times 2 to the power negative 1a plus 6 is equal to 2 to the power 4 times negative 4 is negative 16. You see that? Then what you need to do, remember these are equations, you need to focus on these two. You are using the rules of exponents, which says if we are given here and it's actually a to the power of m times a to the power of n, bases are the same, it's a to the power of what? M plus n. That's what you're going to use. So here you've got 2 to the power 10a plus 5 plus minus 1a plus 6 is equal to 2 to the power negative 16. That's what you're using. You can simplify this to say collect like terms, which is 10a here, now minus 1a plus 5 plus 6 is equal to 2 minus 16. I was collecting like terms, which is 10a minus 1a is 9a plus 5 plus 6 is 11 is equal to 2 to the power negative 16. Then at this stage you wrap it up. There is a rule which says a to the power of m is equal to a to the power of n. Same basis, you say therefore that exponent m is equal to that exponent n. Same thing here, the 2 is the same, therefore we can take that exponent and we can equate them also, so that we've got 9a plus 11 is equal to minus 16. Then you've got 9a is equal to minus 16 minus what? Minus 11. So you've got 9a is equal to 7, which is negative 27. You can check that with the calculator. Then to get rid of the 9 is 9 times a, you divide. The opposite of multiplication is division. What you do on the left, you do on the right. 9 in 27 is 3. So a is equal to negative 3. That's how you solve that. You see that, guys? And you come here to say, okay, I've gotten my answer and I've got that a is equal to minus 3. Can I test it? The question, the answer is yes. How do you test that? You come here and say 32 and then to the power of 2 times negative 3, remember that's the answer, plus 1. Are you seeing that? And then times bracket fraction 1 over 2, and then you close that, and then a is what? To the power negative 3 minus 6. So we find the left hand side, say equal to, say I'm getting a funny number which is 1,65536. remember this 1,65536. I must get the same number on the other side, which is 16 to the power of negative 4, which is 1,65536. It's matching. It means my answer is correct. That was that. So that's how you do that. Let's move on to question 1.2.2, this part. Now 1.2.2, it says what? I think I also worked this one out. Log base A minus 1. Now look what they did. There is a square on the outside with the square is equal to log 10. Are you seeing this? So now when I've got this, I'm able then to say here, let me just bring this all together in a right. Alright, so I've got this, and I'm saying what? I need to solve this. Now there are a few housekeeping things that you need to do here. Look at this. You need to know what is log 10. Log 10, there's the hidden base there. If 10, it must give you a 1. Even the calculator will say log 10 is equal to 1. Let me show you what I mean. If you have got your calculator, there are two logs. There is that log and there is that log. All of them, they talk the same though. Log, if you just see the log, it means there is base 10. If you just put a 10 there and say equal to, it will give you a 1. But if you say log, it forces you to put that 10 and you say of 10, it gives you still a 1. So here there is a hidden 10. You don't have to put it, but that's what it means. Even here there is a hidden 10. You don't have to put it, you can leave it like that. Are you with me? Now, but before that, this can be left out. It's not necessary for now. What we need to do is to get rid of that. Alright, now let me give you again some caution. If I say to you log base A to the power m, right? And then I say also log base A, and then here let's choose real numbers. Let's say this is to the power, let's use actual numbers here. Let's say log base log 9, then I have a 2, and then I have log 9, and then I have a 2, like that. These mean two different things at all. This one means that 2 is same as saying log 9 squared is 81. But this one here, it's same as saying log 9 times is twice. It's 2 of these. The bracket is 2 of these log 9. Even the calculator, you see, if you use a calculator to give us different answers. If I say log 9 log 81, remember I say it is 81, log 81, which is 9 squared, is equal to, I get 1,908. But if I do this and then I say log 9, close that, and then squared, and see if I get 1,08. It's different, you see, 0,9105. So be careful of that. Be careful of that, because it's totally different. So now what does it mean? It means for me to get rid of that square, I must use a square root. But what I do on the left, I do on the right. Now let me just do this, because here I need some caution here. I need some space. Now whenever I put a square root, always don't forget there is a plus or minus. If you forget that, you might lose a solution. So that's how you get rid of that square root, the square, so such that you've got log A minus 1, that one is gone, is plus or minus. I told you log 10 is 1, so it's plus or minus 1. And then you've got two a version of the answers, which is log A minus 1 is equal to the first one, which is a 1, or log A minus 1 is equal to the negative 1 part. As I said, there is a hidden 10 there. Therefore, how do you simplify when you've got that? You are going to say A minus 1 is equal to that hidden 10 to the power 1, or A minus 1 is equal to that 10 to the power negative 1. That's how we convert logs to exponents. Remember, it's very important. That's how you convert logs to exponents. Meaning, if I say to you, I'm given log base A of B if I say this is equal to m, how do I convert this to exponents? You take the a to that exponent m is equal to b, or you start with that b is equal to a to the exponent m. Anything is fine. That's what I just did here. So now, how do you solve for a? Take 1 to the other side, from negative, cross the equal sign, it will become positive. So you have got a is equal to 10 to the power of 1. It's 10 plus 1. So a is 11. 10 plus 1 is 11. Or similarly, take this to the other side, to the from negative, cross the equal sign to positive. Are you seeing that? Similarly, so a is equal to, now 10 to the power negative 1. You can also use a calculator there to say, what is this? 10. What is 10 to the power negative 1? It's 1 over 10. See that? So you've got 1 over 10 plus 1. Now if you use a calculator to say what is 1 over 10 plus 1, you'll get 11 over 10 plus 1 equal to 11 over 10. So a is equal to 11. So I've got two answers. The first one is this, the second one is that. You can test it if you want. So it's 11 and 11 over 10. You can actually come here and say the first one is a is 11, the second one is a is 11 over 10. You can test it. What you do, where there is a, you put the answer. It must give us log 10. Remember, log 10 is equal to what? 1. So let's do that and see if it is going to give us actually the answer here. So you're gonna have a bracket and say log, it opens, and then the first one we say so we are going to start by putting a bracket, the bigger one, on the outside, and then we've got what? Log, and then also we got our a, the first one, say it is 11. See that? It's 11. That's 11 minus 1, and then I close the bracket, and then I close the bigger one squared. See that? Equal to, say I get a 1, and then I can go back here and use the other one is 11 over 10. Again, see if I'm getting a 1. I'm getting a 1. So my two answers there are correct. That's it. Alright. And then last but not least is the second question. This one. 3 marks. Says solve for A, and I'm given this. So how do I go about this? Look at this. I don't think this was difficult, but I just want to find out why they gave it 3 marks, So they are saying to me, I have got A is equal to log 64 in base 64 of 8. Then the question is, I need to find A. Of course, let's use the calculator here. Let's just see what it gives me. They say solve for A in the following equations. I don't think they will give you a mark if they didn't say don't use a calculator, but I don't think they'll give you a mark here. It gives me 1 over 2, but the question is, how do I get here? Don't forget, I got 1 over 2, so my A is simply 1 over 2, but I don't think they'll give you a mark if you just do that. So how do you work this out? There is a rule. Let me use a different marker. There is a rule which says if I'm given log, we've done it before also already, log base A, converting this to exponents, remember, is equal to m. I said what? You take A to the power m is equal to what? Is equal to b. Now if I write it the other way around, the other way around will be m is equal to log in base A of b. So it will be A to the power of m is equal to b. See, this is similar to this version. So if I'm going to follow exactly that one, I will have here to say the M is my A. So what will I have? I will have here A. Sorry about that. Remember, here my A, look at my A. My A is my 64. So I'll have 64. Are you getting that? It's just that I match the A and the A there. But I've got 64 to what? This is, let me just do this to say, in here I have 64 there. In here I've got 8. And in here I've got A. I think that. So the A is the what? This is the 64. The M is the A. The B is the 8. So you see that 64 to the power of A is equal to what? Is equal to 8. Think of it. Now, what is 64? You need to know. 64 is 8 squared. So A to the power 2A is equal to what? Is equal to 8. That's how you solve this. Now, if the bases are matching, then you use this rule, which says here, there is a rule. There is a rule. A to the power of M is equal to A to the power of N. These are matching, therefore you equate that and that. M is equal to N. The key thing is equating that. So the bases are the same, there is a hidden one there. It means that is equal to that. 2A is equal to 1. Divide by 2, divide by 2. There is the answer. There is the half. You see? This means A is 1 over 2. We're asking where did they get, how did the calculator get 1 over 2? So that is that. So guys, we have done question 1. I'm going to do question 2. I wanted to do 2 questions per session so that I can have 3 videos, but looking at the amount of work I need to do, and I don't want these videos too long, I'm going to do 1 question at a time so that they can be manageable for you to focus on 1 question, focus on 2nd question, and so on and so on. So be ready to go come across 6 videos of this memorandum. So every time you finish it, oh, by the way, if it's more than 24 minutes, remember it's called 24-minute lesson. You need to watch it in 24-minute pockets, because your mind can only concentrate for a maximum understanding time of 24 minutes. Anything you do that after that, it's fine. You are developing your brain muscle, you are exercising your brain, you can concentrate further, but just know that you have got a limited or reduced concentration. So if you want to maximize, you can watch it in 24 minutes, take a break, come for the next 24 minutes, take a break, and so on and so on. Okay, so guys, we've come to the end of our lesson. As I said, remember to subscribe to our channel, as well as ensure that the notification bell is turned on. We have come to the end of our lesson. Thank you.